In this video, we're going to take a look at rate of change and slope. They're really the same thing. Rate of change applies to all situations and types of graphs, where slope will only apply to a linear equation. The slope is one specific type of rate of change, so rate of change is the more broad category. Rate of change will always be the change in the dependent variable divided by the change in the independent variable. So in this particular example, we can say that to go from 1 to 2, I'm going to add 1. To go from 260 to 520, I have 260 that I'm adding. So if I want to find what is the rate of change will be given by the 260, which is the change in the dependent variable, over 1, the change in time, which is the independent variable. I can then check and say, okay, what's the change from 520 to 780? In this case, I'm going to add 260 again, as I'm adding 1 as well. So this particular rate would be 260 over 1 as well. And then I can check from 3 to 4 is plus 1, 780 to 1040 is plus 260, so my rate will also be 260 over 1. Okay. There will be situations where these rates will be different, and I'll have to find which one is the greatest, which one is the largest. In this particular case, because these are all the same, what that tells us is that this is actually a linear equation, or the graph will be linear, it'll be a straight line. So I'm actually talking about the slope of this particular equation. So let's take a look at slope. Slope is the rate of change for a linear equation. In order to find m, I'm going to look at what's the change in y over the change in x. So what is the change in the dependent over the change in independent? Oftentimes this is called the vertical change. This is the horizontal change, also called rise over run. Remember, you have to rise, stand up, in order to be able to run. And then if I'm looking at a graph, basically I subtract the two y values, subtract the two x values. So let's take a look at this. I am given a graph, and say one point is at -3, -4, and another point is at 1, -1, 0. Okay, so these are my 2 points, and I have a line kind of going through here, a linear line. What I can do is figure out, okay, how many steps up would I have to go? Since it's up, it's going to be positive. In this case, it's going to be +4. And then how many steps left or right would I have to go? In this case, since I'm going right, it's going to be +2. So my slope will be given by the vertical change of 4 over the horizontal change of 2. In this case, my slope is going to be +2. What I could also do to figure out the slope is, instead of going up and over, I can start, say, at this point right here, and I would have to go down 4. So this would be -4. And then I would have to go left 2. So since I'm going left, it would be negative. So in this case, my slope would be -4 over -2. The negatives will cancel out, and my slope will be +2 as well. Okay. To try to possible answers for you. Okay. In this first situation, anytime I always read a graph from left to right. So if I begin down here and this graph is going up, my slope is going to be a positive slope. So whatever I do to try and find an answer, I can look at it and say that's going to be positive. If I begin higher and I go down, it's what's called decreasing. It's a decreasing graph, but the slope is going to be negative. Okay, and this one, this slope is positive, and it's going to be an increasing graph. Okay. Anytime you have a horizontal line, the slope is going to be 0. One way you might want to be able to read it is if I look at 0 in the z, there's the horizontal lines with an O in the end. Okay, so that's why it's 0. Okay. Reality is because if I try to find the slope, I go up 0 and I can go over however many. So I'm looking at 0 over a number, which gives you a slope of 0. A vertical line is what's called an undefined slope. Okay, and one way of doing it is the u. In order to find u, you kind of go up and down a little bit. Okay, and there's no 0, so this is going to be undefined. The reason being is there is a vertical change, but there is no horizontal change. So I'm going to end up with a number over 0, which is why it's going to be an undefined slope. This reminds me, I forgot to go over that x2, the y2 minus y1. Over x2 minus x1. So if I look back at the same example that I had done, where I took the 2 points, one was at -4, I'm sorry, make that -3, -4, and the other point was at -1, 0. Basically what we're looking at doing is saying, okay, I can set this up beginning with my y values. I could do -4 minus 0, in which case I'm calling this y2 and y1, over then, this would have to be x2, so it would be -3, and this would be x1, so it would be minus a -1. I look at these become positive. Okay, -4 minus 0 is -4, -3 over, or -3 plus 1 is -2, so my slope is +2. Okay, this is one valid way of doing it. What I could also set this up to be is I could go in reverse. I could do 0 minus -4, in which case this would be y2, this would be y1, this would be x2 then, so it has to be over -1 minus my x1, which is -3. Okay, I go through, change signs. Okay, the two negatives will become positive. So then I'll be looking at 0 plus 4, which is +4, -1 plus 3, which is going to be +2, giving me a slope of 2. So this is pretty much just the way the equation works. Basically, the most important thing is that if I begin here with the y's, then down here I need to begin with the x's. So just make sure you're putting x values on top, y values on top, x values on the bottom, and make sure you're being consistent. So -4, -3 is a point, 0, -1 is a point. So just check that. Anyway, that's pretty much slope and rate of change.